Good afternoon, students. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss your Model 4 homework. This is your Model 4 homework. Please, before you continue with this video, it is recommended that you have read your textbook and that you have read the notes and viewed the videos on my website so that you can have a good understanding. As usual, in this video session, we shall just use technology to answer the questions. The two technologies we shall be using are my website and Pearson Statcrunch. So the calculator on my website and also Pearson Statcrunch technology. If you need help with using Excel, Microsoft Excel, then you can just let me know. Okay, but here we shall use the Pearson Statcrunch software and the calculator on my website. Okay, so question 1. The null and alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. What parameter is being tested? So the null, as you can see, this is the population standard deviation, sigma. Okay, sigma is the population standard deviation, equal to 6. And then the alternative hypothesis is that the population standard deviation is not equal to 6. So when you look at the alternative hypothesis, if it is not equal to, that means it is two-tailed. Okay, if it is not equal to, that means it could be less than that or it could be greater than that. So that means it's two-tailed. If it was less than 6, if the alternative hypothesis was that the population standard deviation was less than 6, then it will be one-tailed, which is one-tailed, left-tailed. Okay, if it was less than 6, then it will be one-tailed and then it will be left-tailed. If it was greater than 6, okay, if you look at the alternative hypothesis and then you see that the population standard deviation was greater than 6, then it will still be one-tailed, but it will be right-tailed. It will be one-tailed and right-tailed. But then if you have not equal to, that means it is two-tailed. Okay, two-tailed meaning it could be less, it will be less than, or it could be greater than. So it's not equal to means it's two-tailed. So this is a two-tailed test. Okay, and then what parameter is being tested? This sigma is a population standard deviation. Mu is population mean. Mu is a Greek alphabet. Sigma is also a Greek alphabet. Then population proportion is lowercase p, which is an English alphabet. Okay, but this sigma is population standard deviation. That's it. Okay, later you can look at this. Later you can look at it. Question 2. Determine the null and alternative hypothesis. Explain what it will mean to make a type 1 error. Explain what it will mean to make a type 2 error. So the claim is that 6 years ago, 11.3% of registered births were to teenage mothers. A sociologist believes that the percentage has increased since then. A. Which of the following is the hypothesis test to be conducted? So, look at the thing here. 11.3% is a proportion. When you do 11.3 divided by 100, you have 0.113. So you just converted the percent to a decimal. It's the same thing. Proportion can be in percent, it can be in decimal, it can be in fraction. When the claim, the sociologist believes that the percentage has increased since then. So in this case, your alternative hypothesis, you want to make sure that your alternative hypothesis is what you're claiming. Okay, it's your claim. You want to make sure that the alternative hypothesis is what you believe in, like what you're claiming. And also, you also want to make sure that the null hypothesis has the equality sign. So two things here you have to note. Alternative hypothesis should be something you're claiming. And then the null hypothesis must always have the equal sign. It always have to have the equal sign. The alternative hypothesis could have the greater than sign, it could have the less than sign, or it could have the not equal to sign. Null hypothesis will have the equal sign. Alternative hypothesis should have the less than sign, or the greater than sign, or not equal to sign. Now you might ask me, okay, what if the sociologist believes that it's equal to that? Okay, because in this case, the sociologist believes that the percentage has increased since then. So that is greater than. So the alternative hypothesis should have greater than sign, because increase since then is greater than sign. Okay, now, but what if the sociologist believes that it's equal to then? Then you want to make the alternative hypothesis to be not equal to. Yeah, but you always want to keep your null hypothesis to be equal to. Okay, that's what you want. So, but in this question, a sociologist believes that the percentage has increased since then, so greater than. So as you can see here in the options, okay, null hypothesis you always want to make sure is equal to. Alternative hypothesis is greater than. So the answer here is A. The correct option is A. Then, which of the following is a type 1 error? So, the default is our null hypothesis. Okay, take the null as your default. Take it as the conventional one, as the main one, as the default. So, when the null hypothesis is true and you reject it, that means it's a type 1 error. When the null hypothesis is not true and you fail to reject it, okay, if you fail to reject it or if you do not reject it, you know it's not true, but you do not reject it, okay, then is a type 2 error. Okay, some students will say, okay, why don't you want to use the word accept it? Accept. Why do I have to say do not reject it? Or do fail to reject it? Fail to reject the null hypothesis and do not reject the null hypothesis. It means the same thing. Why can't you just say accept the null hypothesis? Well, we are not trying to prove the null hypothesis. We're not trying to prove the null hypothesis. We are just trying to make a hypothesis test. When you develop your hypothesis, okay, developing hypothesis or hypothesizing about something, forming a hypothesis is one of the scientific methods. You form a hypothesis. Well, in statistical methods, which is also, that's why statistics is a science, because the statistical methods are identical to this, is the same steps to the scientific methods. When you form a hypothesis, okay, form it as alternative. Let that claim be your alternative. The null is just like in contrast to your alternative. Okay, just like in contrast to your alternative. So you're now trying to see, okay, would you reject the null or would you fail to reject the null? In essence, okay, in essence, if you fail to reject the null, okay, it means do not reject the null. In essence, that means accepting it. Okay, in essence, it means you're accepting the null. But we don't want to use the word accept. Okay, that's the terminology. We say do not reject the null or fail to reject the null. And then also, in essence, when you reject the null, that means in essence you're accepting the alternative hypothesis. Okay, but we're not saying accept. We don't use the word accept the alternative hypothesis. We just say, okay, reject the null or do not reject the null or fail to reject the null. So type 1 error means that the null is true and you rejected it. So you look at these options. The sociologist rejects. The sociologist fails to reject. The sociologist rejects. So you look at option B is out of the case already. Remember, our default is the null. Okay, so type 1 error will be that the null is actually true. The population proportion is 0.113 and you reject it. That is the type 1 error. Yes, that it is true that the population proportion is actually 0.113, but you reject it. Then that is a type 1 error. So if you look at A and C, okay, if you read A and C, they say A is the sociologist rejects the hypothesis that the percentage of births to teenage mothers is 11.3%, which is 0.113. When it is actually the true percentage, then that is a type 1 error. Okay? Then type 2 error, I think that's the next question they will ask. Type 2 error means that the null is not true, but you fail to reject it. Fail to reject, like I said, means you accept it. It's not true, but you went ahead and accepted it. But we don't use the word accept. We just say the null is not true, but you fail to reject it, which means in essence that you accepted it, but we don't use the word accept because we're not trying to prove anything. So we're just testing the hypothesis. That's what we're doing. So the null is not true, but you fail to reject it, or you do not reject it. Okay, that is type 2 error. So you look here, option B is out because it says rejects it. No, it should be either fails to reject. So it should be either A or C. So let's look at A. The sociologist fails to reject the hypothesis that the percentage of births to teenage mothers is 11.3% when the true percentage is greater than 11.3%. You look at option C. The sociologist fails to reject the hypothesis that the percentage of births to teenage mothers is 11.3% when it is the true percentage. So you look at A and C. Remember, type 2 error means the null is not true, but you fail to reject it. You do not reject it, even though it's not true. Okay, so it can be C because type 2 error means the null is not true, so it can't be C. So the answer would be A. Okay, the null is not true, but you fail to reject it. The true value is that it's greater than 0.113, which is the alternative. Okay, that's the actual thing that is true. The null is not true, but you fail to reject it. Okay, so that's why it has to be A. You fail to reject the null even though it's not true. It's not going to be C. C means you fail to reject the null even though it's true. No, that's not a type 2 error. Okay, so type 2 error means the null is not true, but you fail to reject it. You do not reject it, even though it's not true. You fail to reject it. Type 1 error means the null is true, but you reject it. That's the type 1 error. Okay? So by the time we do more problems, it will make more sense, okay? Question 3, determine the null and alternative hypothesis. That's the A part. B, explain what it will mean to make a type 1 error. And C, explain what it will mean to make a type 2 error. The claim is this: 3 years ago, the mean price of a single family home was $243,744. A real estate broker believes that the mean price has decreased since then. So this is the belief of the real estate broker. So that means the alternative hypothesis would be that the mean is less than. Okay, a real estate broker believes that the mean price has decreased since then. Okay, so 3 years ago, the mean price was $243,744. Okay, a real estate broker believes that mean price has decreased since then. So that's the alternative hypothesis. Remember, the null will always have a equality sign. Okay, and this is population mean. So because the mean price has decreased since then, it has to be alternative hypothesis. And that is this. That decrease is that less than here. Okay, so it's A. Okay, next one. Which of the following is a type 1 error? Type 1 error means the null is true, but you reject it. Okay, the mean price is actually $243,744, but you reject it. So, you see here, the option will not even be C at all. Remember, the null is our main default. Okay, so the option could be A and B because you reject the null. So it could be A and B, but if you read A, it says the broker rejects the hypothesis that the mean price is $243,744 when it is the true mean cost. Is the true thing, but you reject it. That's type 1 error. Okay. Type 2 error means that the null is not true, but you fail to reject it. Okay, the null is not true, but you do not reject it. It is not true, but you do not reject it. That is type 2 error. So C is out of the case. By elimination, you eliminate C. The answers should be either A or B. A or B. A, the broker fails to reject the hypothesis that the mean price is $243,744 when the true mean price is less than that. Okay, remember the alternative is that the true mean price is actually less than that. That's the alternative. In essence, when you reject null, in essence, that means you are accepting the alternative. That's in essence. And when you fail to reject the null, that means you're rejecting the alternative. In essence, okay? So, fail to reject is what we use rather than accept. We don't want to use accept. But I don't want this to confuse you at all. You can put it in your mind that it's accept, but later you convert it that it is fail to reject or do not reject. Okay? So, type 2 error, you fail to reject it when it is not true. The null is not true, but you fail to reject it. You did not reject it, even though it wasn't true. You still accepted it. You did not reject it, even though it was not true. Okay? So the true mean price this is not the true mean cost for type 2 error for B. Okay? The true mean price is less than that, but you still did not reject that null. So this is A. Okay? I hope this is making sense to you. Okay? Question 4. Suppose the null hypothesis is not rejected. State the conclusion based on the results of the test. Okay, the claim 6 years ago, 12.9% of registered bets were to teenage mothers. A sociologist believes that the percentage has increased since then. So with the conclusion, when you make your decision whether to reject the null or whether to fail to reject the null, that is your decision. What will be the conclusion? The conclusion is that if you reject the null, okay, then you will say that there is sufficient evidence to support the rejection of the null hypothesis. Okay, if you reject the null, if the decisions are either to reject the null hypothesis or fail to reject the null hypothesis. Fail to reject the null hypothesis means do not reject the null hypothesis. So if your decision was to reject the null hypothesis, then the conclusion would be that there is sufficient evidence. There is sufficient evidence to support your decision. Your decision was to reject the null hypothesis. So the conclusion would be, yes, you have sufficient evidence to reject that null hypothesis. If your decision was to fail to reject the null hypothesis, then your conclusion would be there is insufficient evidence to support the rejection of the null hypothesis. Okay, I want you to just take this in mind, okay? If your decision is to reject the null hypothesis, conclusion would be there is sufficient evidence to support that your decision. There is sufficient evidence to reject the null hypothesis. If your decision was fail to reject, do not reject the null hypothesis, or fail to reject the null hypothesis, then your conclusion would be there is insufficient evidence to support the rejection of the null hypothesis. Okay, there is insufficient evidence to support the rejection of the null hypothesis. And then, of course, remember, rejection of the null hypothesis, in essence, okay, the rejection of the null hypothesis, in essence, means supporting the alternative hypothesis. Okay, in essence, yeah, but if your decision is to reject the null, conclusion will be there is sufficient evidence to reject the null. If your decision is fail to reject the null, then your conclusion will be there is insufficient evidence to support rejection of the null. So if you read this now, which of the following is the correct conclusion? You do not reject the null. Okay, so we are looking at either B or D, because if you fail to reject the null, conclusion will be there is not sufficient evidence to support rejection of the null. So you're looking at B or D. B, there is not sufficient evidence to conclude that the percentage of teenage mothers has increased. D, there is not sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Okay, so if you look at this now, there is not sufficient evidence to reject the null. The null will be that the percentage of teenage mothers is 12.9%. The alternative will be that the percentage is greater than 12.9%. Alternative is what you believe in. And that's going to be a one-tailed test, and it's going to be right-tailed. Okay? So, rejection of the null, I want to explain all this to you so you get it at first try. You really understand it. So, rejection of the null will be okay. Rejection of the null will be okay. In essence, accepting the alternative. And accepting the alternative is that the percentage has increased since then. Okay? That is in essence what it means. Rejection of the null means accepting the alternative, which is that the percentage has increased since then. So you will now say, okay, there is not sufficient evidence to reject the null, meaning there is not sufficient evidence to accept the alternative. In essence, that is what it means. There is not sufficient evidence to accept that alternative hypothesis. So this will be, there is not sufficient evidence to conclude that the percentage of teenage mothers has increased. And that is B. Okay, I hope you understand it. Okay. You can look at this later on. Question 5. Suppose the null hypothesis is rejected. Okay, state the conclusion. Remember, if your decision is to reject the null, then the conclusion will be there is sufficient evidence to support your decision. So there is sufficient evidence to support rejection of the null. That is your conclusion. Okay, so the claim here, 3 years ago, the mean price of a single family home was $243,706. A real estate broker believes that the mean price has increased since then. So in this case, your alternative is greater than. Okay, your alternative is greater than, and that is one-tailed, right-tailed. The null is that the mean price, mu, okay, the population mean is equal to 243,706. So you reject the null. You reject it. So there is sufficient evidence. Now, if you reject the null, that means in essence you're accepting the alternative. Okay, in essence. So the conclusion is there is sufficient evidence to reject the null. So in essence, it will be there is sufficient evidence to accept the alternative. Okay, I'm using the word accept because I want it to make clear, like I want you to really understand it. Okay, so there is sufficient evidence to reject the null means, in essence, there is sufficient evidence to accept the alternative. And that alternative is that the mean price has increased. So there is sufficient evidence. So B and D are the options you should be looking at. A and C are out by process of elimination. So we look at B. There is sufficient evidence to conclude that the mean price of the single family home has increased. And that is sufficient evidence to accept the alternative, which is that it's increased. D, there is sufficient evidence to conclude that the mean price of the single family home has not changed. You see, it's not going to be D, no, because you're rejecting the null. Okay, so there is sufficient evidence to support that rejection of the null, which means, in essence, there is sufficient evidence to accept the alternative, which is that the mean price has increased. And that is B. Okay? All right. Here, critical values. Okay. Critical values. I'm going to just pull up. We're now in calculations. So let me open up another web browser, Firefox. I'm going to use my calculator to do this question. So just let's go to google.com. Let's get on my mobile friendly site. Okay, Samuel Chukwuemeka AppSpot. Click on this here. Let's get on portfolios and look at these apps. Hypothesis testing calculator. Okay, you can also get this under statistics. Hypothesis testing calculator. So this is what we're going to use here. The critical value for the critical value, because some of you might ask me, okay, why don't I use the critical value? the critical Z for inferential statistics. Well, that is for inferential statistics. Here we are going to use is critical value, but we are not using alpha over 2. Okay, we're going to just use alpha. So this is the calculator you will use. If you get to this calculator, testing a claim about a population proportion. Okay, and the question, left-tailed test. Okay, so we're going to use left-tailed, one sample left-tailed. Let's put this like this. So one sample left-tailed is what we're going to use, because this is critical value for left-tailed test. Level of significance is 0.10. Okay, so you come here, one sample left-tailed, and you just scroll down here, scroll down, level of significance is 0.10. So you put 0.10 and you make sure you select decimal. Please don't put percent, please. Okay, make sure it's decimal because this is in decimal, and click calculate. So the critical value, round to 2 decimal places as needed. So the critical value is negative 1.28. So this is negative 1.28. Okay, that's your answer. Question 7, test the hypothesis using the classical approach and the p-value approach. So you have the null. The null hypothesis is the population proportion is 0.50. The alternative hypothesis is that the population proportion is less than 0.50. So you look at this here, this is left-tailed because this is less than left-tailed. So come back to this calculator. It's still left-tailed, so just it's still one sample left-tailed. So just scroll down. Just scroll down. This is test hypothesis using classical approach and p-value approach. So the population proportion here is 0.50, and please make sure it is decimal. If you put percent, it will give you wrong answer. This is in decimal because, like I said, proportion could be in decimal or in percent or in fraction. Okay, but in this case it's decimal. The number of individuals with the specified characteristics, that is x is 66. Sample size is n, which is 150. Level of significance alpha is 0.10, and that is in decimal. And you click calculate. Remember, this is left-tailed. Make sure you select left-tailed. Okay, so I gave there is, you know, with this, the nice thing about this calculator is I wrote it in a way that it gives you a lot of values, a lot. Okay, so we could really answer it right away. Perform the test using classical approach. Choose the correct answer below. The classical approach, if the test statistic is less than critical Z, you reject the null hypothesis. Okay, if it is less than or equal to, if the test statistic is less than the critical Z, just reject the null. So this will be reject the null. Okay. Perform the test using p-value. What is the p-value? So we can see the p-value here, and they say round to 4 decimal places as needed. So p-value is this, so we put it 0.0708. 0.0708. Okay, that's the p-value. Enter. Okay, and of course, even with the p-value is less than or equal to the, if the p-value is less than or equal to the level of significance, you reject the null. If the p-value is greater than level of significance, you fail to reject the null. So in this case, you still reject the null. Okay? All right. Question 8, you can look at this later on. Let me sort of, let me close this and want to make sure. Okay, this is still under population proportion. Make sure, remember, you have population mean and then population proportion. Just make sure it's here, because this is still on proportion. I hope you can see this well. Okay, in a clinical trial, 20 out of 800 patients taking a prescription drug complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there sufficient evidence to conclude that more than 1.9% of these drugs users experience flu-like symptoms as a side effect at the 5% significance level? Okay, that is 0.05 level of significance, 5%. Okay, so now you look at this question. Is there sufficient evidence to conclude that more than 1.9%, suppose it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms? Is there sufficient evidence to conclude that more than 1.9% of these drugs users experience flu-like symptoms? So this is the belief here, more than 1.9%. Excuse me. So the alternative is greater than alternative greater than 1.9% is 0.19. Okay? 1.9 divided by 100. Sorry, 0.019. My bad. 0.019. Okay? Is 1.9%. Are you guys with me? So that's the alternative, what you believe in. Okay? More than 1.9%. So the null, like I said, is always equal to. The null is always equal to. So this is 0.019. That's the null. So this is your null hypothesis. This is the alternative hypothesis. Okay? Use technology to find the p-value. Okay, so I'm gonna use let's do this question with my calculator. Then we will also do it with Statcrunch. How about that? So this is, because of this alternative here, greater than, this is a right-tailed. So you click on one sample right-tailed. You click on it, one sample right-tailed, and just scroll all the way down to this test hypothesis using this classical approach and p-value approach. So population proportion is 0.019, and this is in decimal. If you have to use percent, you can also use 1.9%. That's fine. If you want to, you can use 1.9%. Okay? Actually, I can use it 1.9, but make sure you put it in percent. Okay? Just make sure. Number of individuals here is 20 out of 800 patients. Okay? Level of significance is 0.05, and that is in decimal. Calculate. So you calculate, it gives you all these. P-value to 3 decimal places would be 0.107. 0.107. Okay? Okay, that's it. And then choose the interpretation. The p-value approach. The p-value, if it's greater than the level of significance, do not reject the null. Do not. Okay, do not reject the null hypothesis or fail to reject the null hypothesis. So you look at these options, it could be A or B. C and D are out, process of elimination. So it could be A or B. So A, since p-value is greater than the level of significance, do not reject the null and conclude there is not sufficient evidence. You see, the conclusion is also there for you. Okay, so the answer is A right away, A, okay? Alrighty. If you want, let me show you this question with Statcrunch. How about it? I can show you. So let me just minimize this, maximize this. With this question here, go to question help, go to Statcrunch. You come over here, start, you go to Z stats, actually proportion stats, I mean proportions, you go to proportion stats. Okay, this population proportion, this is one sample with summary, one sample with summary. Number of successes is your X is 20. Number of observations is your sample size, 800. We want to perform hypothesis test, okay? P in this case is 0.019. And the alternative hypothesis is greater than. So you click here, select greater than, okay? Is a right-tailed, one-tailed, and is right-tailed. So make sure this is selected, hypothesis test. And you just click compute, okay? When you click compute, you can see it here. The p-value is 0.107. See that? If you round to 3 decimal places. Okay? And of course, by your readings and viewing the videos, you now know the conclusion. Okay? But my calculator, I also put the conclusion, so it's easier for you. So that's the way you do it with Statcrunch. Let's minimize this. Or you know what, let's close it. Next question. All right, so this question is still proportion. We will do it with both, okay, with both my calculator and also with Statcrunch. Several years ago, 41% of parents who had children in grades K through 12 were satisfied with the quality of education the students receive. A recent poll asked 1,175 parents who have children in grades K through 12 if they were satisfied with the quality of education the students receive. Of the 1,175 surveyed, 491 indicated that they were satisfied. Construct a 99% confidence interval to assess whether this represents evidence that parents' attitudes toward the quality of education have changed. Okay, so if you look at this, you want to see whether the parents' attitudes towards the quality of education have changed. Whether they have changed. So in this case, it will be a two-tailed, not equal to. Okay? We want to know whether the parents' attitudes towards the education have changed. This didn't tell you directly whether it is less than, whether it's whether their attitudes, whether their satisfaction level has increased or decreased. They just say have changed. Okay, so this is not equal to, is a two-tailed test. Okay, so just, that's the way you know that. And then the population proportion, of course, this is several years ago, 41% of parents who had children. So 41%, 0.41. So this is 0.41. And then the null will always be equal to, okay, 0.41. That's the null. So that's your hypothesis. The null hypothesis and alternative hypothesis. The next one, use technology to find a 99% confidence interval. All right, so we'll do it with my calculator, then we'll do it with Statcrunch. How about that? I close this. So with my calculator, just do, this is one sample, two tails. One sample, two tails. So click on it. And here, confidence level is 99%. Select percent here. Number of individuals here. Number of individuals. The X of the 1,175 surveyed, 491 is the number of individuals with the specified characteristics. Sample size is 1175. And the population proportion is 0.41. Calculate. So when you click calculate, you see all these. Okay. You just look at confidence interval method. You use confidence interval method when you have a two-tailed test. You're testing a claim about a population proportion and it is two-tailed. You use confidence interval method. So but this is the 99% confidence interval. So round to 2 decimal places. This will be 0.38. the lower confidence limit, and then 0.46 upper confidence limit. Okay. Now, what is the correct conclusion? There is not sufficient evidence to support rejection of the null. So the confidence interval actually contains the population proportion. Population proportion is 0.41. And you look at this here, these two intervals. 0.41 is contained in this confidence interval. So because the interval contains the population proportion, then there is not sufficient evidence to support rejection of the null hypothesis. Okay. So process of elimination, B is out, does not contain, and D is out. So we're looking at A and C. A, since the interval contains the proportion stated in the null hypothesis, there is insufficient evidence that parents' attitudes towards the quality of education have changed. Okay, there is not sufficient evidence means there is insufficient evidence. Okay, so the answer is A. Okay. I can show you with Statcrunch. Let me show you with Statcrunch. Let me minimize this, maximize this. So with Statcrunch, go to question help, go to Statcrunch. Okay, go to Stat. You're looking at proportion stats, one sample with summary. Okay, it's still one sample with summary. All right. Let's make this small. Let's restore this. Okay. So X in this case is 491. Number of observations is 1175. Perform hypothesis test. This is 0.41. An alternative hypothesis is two-tailed, so that's fine. You leave it there. Make sure this radio button is checked. Hypothesis test for P. And just click compute. And then it shows you the the p-value. They didn't ask for the p-value, right? Yeah, in this case, they didn't ask for the p-value. But for the confidence interval, yeah, this is two-tailed. So if you want to get confidence interval, actually, go to start, proportion stars, one sample with summary. This is 491, this is 1175. Go to confidence interval instead. Confidence interval, and this is 99% will be 0.99. Leave it as standard word and compute. And you will now see this, the lower limit 0.38 and the upper limit 0.46. I think it will accept 0.45. It should. Okay? So that is how you do it with Statcrunch. That's how you do it with Statcrunch. Alrighty. Next one, question 10. Almost getting there. In a survey, 31%. So this is also population proportion. Proportion is percent or decimal or fraction. In a survey, 31% of the respondents stated that they talked to their pets on the answering machine or telephone. A veterinarian believed this result to be too high. So he randomly selected 150 pet owners and discovered that 42 of them spoke to their pet on the answering machine or telephone. Wow. People will be speaking to their pets on the answering machine. Wow. Does the veterinarian have a right to be skeptical? Use the 1% level of significance. All right, folks. Let's look at this now. The veterinarian believed this result to be too high. So the result they are talking about is 0.31. That's the population proportion. And he really believed this to be too high. So actually, what does he believe? He believes that to be less than. He believes that this is less than. So kind of that's like the trick in this question. He believed this result, this 31%, to be too high. So actually, he believed if he or she, I'm sorry, I'm using he. It could be he or she, okay? okay. Because females are also vets, right? Okay, so the vet believed this to be too high. So that means he actually believed this number to be decreased. So that is less than 0.31. And that is the alternative. Now the null will always have equal to 0.31. Okay? Round to 2 decimal places as needed. Yeah. Okay? Use technology to find p-value. All right. So I like using my calculator because it tells you everything. That's why I like using it. So I'm going to come here. This is left-tailed. Okay, this is left-tailed. One sample left-tailed. And just scroll down. Reset this. Just go ahead and reset it. I want this to, yeah, one sample left-tailed. You see, this is still doing the, that's fine. Just type in your distance, it will change. Population proportion is 0.31, and that is in decimal. You can use 31, but you have to put percent. Okay. Number of individuals is 42. Sample size is 150. Significance level is 0.01, 1%. But put decimal. You can also put 1 and you put percent. Okay. So let's see here. P-value. P-value is 0.215 if you round to 3 decimal places. 0.215. Okay. And what is the conclusion? p-value is greater than the level of significance, so do not reject. If p-value is less than or equal to level of significance, then you reject the null. If p-value is greater than the level of significance, do not reject the null. Okay, so this is with p-value approach. So, and then conclusion, there is not sufficient evidence, which means there is insufficient evidence to support rejection of the null. So, process of elimination, A is gone and D is gone. So, let's look at B and C. There is not sufficient evidence to conclude that the population proportion of pet owners who talk to their pets on the answering machine or telephone is 31%. Okay, remember, there is not sufficient evidence to reject the null. So, which means there is not sufficient evidence to accept the alternative. That is what it means. In essence, that is what it means. So, there is not sufficient evidence to say that the proportion is less than 31%. That is the conclusion. There is not sufficient evidence to support rejection of the null. Okay, so which means in essence, there is not sufficient evidence to support the acceptance of the alternative. Acceptance of the alternative is that the proportion is less than 31%. So in essence, that is what it means. So the conclusion is there is not sufficient evidence to support that the proportion of pet owners who talk to their pets on the answering machine or the telephone is less than that. So you look at B and C, okay, and you see that the answer will be C. Okay, so please take note of that. Okay, question 11. I'm just gonna use Statcrunch from now on for the T, critical T. Question 11. There is something I want to teach you with Statcrunch regarding this critical T. Very important. If you want, you can also use my calculator, but there is something I want to teach you here. Determine the critical T. And we did this critical T actually. You can even use the calculator on inferential statistics. Inferential-statistics.appspot.com. You can use it for this particular question. You're finding the critical T. If you have to use Statcrunch for this, there is something you need to know. So let me minimize this. Go to question help, open up Statcrunch. I want to show you something, especially for questions B and C. I explained that in the previous video, but there is an addition in this particular video that you need to know if you want to know how to use Statcrunch to do it. The first question, determine the critical T, right-tailed, is going to be right-tailed of the population mean, 5% level of significance, 10 degrees of freedom. Go to Stat, go to Calculators, okay? Not T-Stats, but Calculators, and click on T. You click on T, and then it's 10 degrees of freedom right here, okay? And this is where you want the 5% level of significance, and this is right-tailed. So 5% is 0.05, okay? But this shows left-tailed, so you have to put it right-tailed. So you click here and you select this. This is right-tailed, okay? And you have to round to 3 decimal places. So this is 1.812. So you come here. Now for right-tailed is plus. Okay, plus right-tailed, and you put 1.812. Okay. Then B, determine the critical T population mean is of a population mean at 1% significance level based on sample size of 20. Okay, if you look at this Statcrunch, there's no sample size. They only give degrees of freedom. So in this case, this is one sample proportion, and we are just testing. We are just testing a claim about the population mean. So one parameter, which is mean, population mean, that is only one parameter. When you have one parameter, degrees of freedom is n minus 1. N minus 1. Okay? Degrees of freedom is n minus 1. And this is left-tailed. So degrees of freedom, excuse me, will be 20 minus 1, which is 19. In this case, 19. And the level of significance, you still use it as 0.01. And you want left-tailed. This is right-tailed. You want left-tailed. So you click on this. Left-tailed. You see that? So when you have the sample size, degrees of freedom is, if you have the sample size, okay, and you're only one parameter, in this case the parameter is population mean, then degrees of freedom is n minus 1, the sample size minus 1. If you're given the sample size, you're not given the degrees of freedom, and you have to use Statcrunch to do it. Then you look at how many parameters are being tested. It's one parameter, which is population mean. So degrees of freedom will be n minus 1, which in this case is 20 minus 1, which is 19. So the critical T is negative because it's left-tailed, and it's negative 2.539. Okay? C, determine the critical T for a two-tailed test of population mean at a 5% level of significance based on a sample size of 11, and it's equal to 11. Okay, so when you have a two-tailed test, if you have a two-tailed test, it could be less than or it could be greater than. Okay, so I want you to note at least two things here. The values could be plus or minus. Okay, it could be greater than, it could be less than. That's number one. Number two, actually note three things, okay, because they gave us sample size. So sample size and the parameter, we only have one parameter being tested, and that parameter is population mean. So the degrees of freedom will be 11 minus 1, okay, because you have one parameter being tested. So degrees of freedom is 11 minus 1, and that is 10. Okay, we have 10 here. The third thing to note with two-tailed test, please, very important. The third thing to note is that the level of significance, you have to divide it by 2. Okay, so you have to do 0.05 divided by 2. Level of significance is, you don't use 0.05. Okay, in this case, whatever they give you, just divide it by 2. So which is 0.025. Okay. And I know this is left tail, that's fine. We are just interested in the value here. And that should give us 2.228. 2.228. Okay? That is the thing to note. With two-tailed test, it has to be plus minus and then use alpha over 2. Okay, for two-tailed test. Okay? All right. Next question, question 12. We're almost getting there. To test this, they give us the null hypothesis and the alternative hypothesis. This is a two-tailed test. A simple random sample size of n equal to 20 is obtained from a population that is known to be normally distributed. Okay. Compute the test statistic. Okay, we're gonna do this with Statcrunch. Minimize this. Okay, Statcrunch. Okay. For this question, go to Start. Go to T-Stats. T-Stats, not calculators and pick T, no. Okay. Here we are testing a claim about a population mean. So go to T-Stats, one sample with summary. Here the sample mean X bar is 104.5. Standard deviation is 9.5. Sample size is 20. Perform hypothesis test for the mean. The mean in this case is 100. And this is a two-tailed test. Alternative is not equal to 100. Okay? And then click compute. Compute the test statistic is this T-stat. That's the test statistic. And that is 2.118. Okay? 2.118. Now, if the researcher decides to test this hypothesis at the 0.011% level of significance, determine the critical values. Okay, so with the critical values, this is what you do. Okay, close this. Go to Start, go to Calculators, go to T. This is 0.01 level of significance. So you divide it by 2. If you divide it by 2, what do you have? 0.005. Okay, because remember you have to divide by 2. If it's two-tailed test, you have to divide by 2. Degrees of freedom is 20 minus 1, and that is 19. 19. Okay. And you just click compute. Now, the critical values are minus and plus. Okay, it has to be both minus and plus. So it says use a comma to separate answers. Round to 3 decimal places as needed. Yeah, because this is minus and plus because it's two-tailed. Okay, it could be greater than or it could be less than. Okay, greater than is for the plus, less than is for the minus. So not equal to means it could be greater than or it could be less than. So it's two-tailed. So this will be negative 2.861, comma, negative 2.861, and then negative 2.861. Okay? All right? That is the critical values. And then T distribution to do that will be, is two-tailed. So two-tailed, and that is this, CPAT. Okay? Would the researcher reject the null hypothesis? Okay, so with population mean, you see the T-stat, you look at this now, the T-stat. Is it included in this? You look at this, compare the T-stat and the critical values. You compare 2.118. Is it included in this interval? You look at that. So if it's included, then you then there is not sufficient evidence to reject the null. Okay, if it's included in that, then do not reject the null. First of all, do not reject the null, and there is not sufficient evidence to reject the null since it is included. Okay, so there is not sufficient evidence for the researcher to reject the null since the test statistic is between the critical values, is between. I call it included, but it's between that. 2.118 is in between this. Okay, at least it's greater than negative 2.861 and it is less than 2.861. So there is not sufficient evidence for the researcher to reject the null because the test statistic is between the critical values. Okay? All right. Question 13. Later on, you can look at this instructor tip. You can look at it later on. This is also to test the null versus the hypothesis. So you look at this, a simple random sample of size n equal to 17 is obtained from a population that is known to be normally distributed. Okay, we want to find a test statistic. Okay, so this is a left-tailed. As you can see, this is left-tailed test. One-tailed and it's left-tailed. So open up Statcrunch. Go to Stats, T-Stats, one sample with summary. The sample mean is 18.4, that is your X bar. Sample standard deviation is 4.5. Sample size is 17. Test the hypothesis, population mean is 20. And then alternative is one-tailed, left-tailed. So click here and select less than. Okay, make sure select less than, and then click compute. So the t-stat is negative 1.4, round to 2 decimal places. So negative 1.47 is the test statistic. Okay. If you want to plot it, this is left-tailed. Okay, it's left-tailed, so it's gonna be C. Okay, and if you want, you can also use Statcrunch to plot it as well. P-value is 0.081. 0.081. So they just say approximate the p-value. 0.081 lies between what? If you look at the options, 0.081 lies between B, option B, 0.05 and 0.1. So that's it. Okay. And what will be the, if the researcher decides to test this hypothesis at the level 0.05 level of significance, will the researcher reject the null hypothesis? So in this case, they want us to use the p-value approach. Okay, so with the p-value approach, if the p-value is less than or equal to the level of significance, then reject the null hypothesis. If the p-value is greater than the level of significance, then do not reject the null. So let's find the p-value actually is 0.081. Level of significance is 0.05. So p-value approach. So 0.081 is greater than 0.05. So the p-value is greater than the level of significance. So do not reject the null hypothesis. Do not reject it. Okay? Because the p-value is greater. So it's not like, so it's either B or C. So you will not reject the null because the p-value is not less than level of significance. So that's it, B. Okay. Question 14. Let's close this. Several years ago, the reported mean age of an inmate on death row was 42.9 years. A sociologist wondered whether the mean age of a death row inmate has changed since then. She randomly selects 41 death row inmates and finds that their mean age is 44.7 with a standard deviation of 10.7. Construct a 90% confidence interval about the mean age of death row inmates. What does the interval imply? So the sociologist wondered whether the mean age of a death row inmate has changed since then. So this tells you that it is what? They don't know whether it is less than, he or she doesn't know whether it is less than or greater than. So it's a two-tailed test. Okay, so and this is mean. So the mean is not equal to 42.9 because the sociologist wondered whether it has changed since then. So it's a two-tailed test. So the null hypothesis will be the mean and it has to be equal to. So it's a two-tailed test. Okay. Check answer. Okay. Construct a 90% confidence interval about the mean age. I'm going to open up Statcrunch. Okay. Go to Stat. Go to T-Stats. One sample with summary. Okay. Excuse me. So the sample mean, she sampled 41 inmates, found the sample mean to be 44.7. Excuse me. Sample standard deviation 10.7. Sample size is 41. Just click on confidence interval, okay, not hypothesis test. Confidence interval 90%, 0.90 or 0.9, okay, and compute. So the lower limit is 41, excuse me, round to 2 decimal places. So the lower limit is 41.89. Upper limit is 47.51. Okay. All right. What does the interval imply? So the mean is 42.9. Is it in between this interval? As you can see, 42.9 is in between this interval. So since the given mean age is in the interval, reject the null. No. Of course, if the given mean age is in the interval, that is why you should not reject the null. Okay? So since the given mean age is in the interval, do not reject the null. Okay? All right, last but not the least, question 15. It has long been stated that the mean temperature of humans is 98.6 degrees Fahrenheit. However, 2 researchers currently involved in the subject thought that the mean temperature of humans is less than 98.6 degrees Fahrenheit. So these 2 researchers thought that the mean temperature is less than. So this is one-tailed and it is left-tailed. The alternative hypothesis is less than. It is one-tailed and it is left-tailed. They measured the temperatures of 148 healthy adults 1 to 4 times daily for 3 days, obtaining 600 measurements. The sample data resulted in a sample mean of 98.4 degrees Fahrenheit and a sample standard deviation of 0.7 degrees Fahrenheit. Using the classical approach, judge whether the mean temperature of humans is less than 98.6 degrees Fahrenheit at 1% significance level. And then B, approximate the p-value. Okay, Question help Statcrunch. Okay, excuse me. Let's go ahead and test this claim. T starts one sample with summary. The sample mean they found out was 98.4 degree Fahrenheit. Sample standard deviation 0.7 degree Fahrenheit. Sample size, how many adults did they measure? 148 adults. Test hypothesis, the null hypothesis is 98.6, the mean 98.6. An alternative, they thought that is less than. So this should be less than. It is left-tailed, one-tailed and left-tailed. Okay? And you click compute. Choose the correct answer below. So T starts, the test statistic we have here is negative 3.4758643. Let's round it to 2 decimal places. That would be negative 3.48. Okay, T start is negative 3.48. So let's keep that in mind. We will compare the test statistic and the critical value. So if the test statistic falls within the critical value, we shall reject the null right away. Okay, because you have if it falls within the critical region, we're gonna reject the null. So if it is greater than, if the test statistic is greater than the critical value, if it doesn't fall within the critical region, then we do not reject the null. Okay, if it's greater than that, we will not reject the null. But if it is less than the critical value, then we are going to reject the null. So the T start is negative 3.48. Find somewhere and write it down. Just find somewhere and write it down. Negative 3.48. The next thing we're gonna do is we go to start. We go to, let's get the critical value. Okay, so calculate us T. This is a left-tailed, so we're gonna use alpha as it is, which is 0.01. Left-tailed. Degrees of freedom in this case, we are testing only one parameter, population mean. So 148 minus 1. So we use n minus 1 degrees of freedom. 148 minus 1 is 147. Okay? Compute. Now this is the critical region here. Negative 2.35. Rounded to 2 decimal places. But the other one we had was what? Negative 3.48. Negative 3.48. You see that? T start. And then here is negative 2.35. So as you can see, negative 2.35 is greater than negative 3.48. So the test statistic falls within the critical region. It falls within it. And because it falls within the critical region, reject the null. Okay, so it's less than the critical value. So reject null because test statistic is less than critical value, period. Okay? And then what is the p value? Close this. P value as we have here is 0.0003. Round to 4 decimal places. 0.0003. Okay. I think that is it. So let's close this. Folks, that is it. And you just click save. So thank you so much for listening to this video presentation. As usual, if you have any questions, please feel free to contact me. If you are my student, please contact me through the school system. If you are not my student, then you can contact me from my website. Thank you for listening, and you have a great day.